Howdy and welcome back. So we'll go ahead and finish out this lesson with a brief discussion on some of the limitations of arrays. So first and foremost, we talked about how we're placing these arrays on the stack. We have acknowledged that a little bit later in the course, we'll introduce arrays on what's known as the free store using dynamic memory, which will get around this limitation. But for now, we're going to go ahead and say that the arrays that we're familiar with at this point in the course, the size of them must be known at compile time. This is when we're actually converting our code into an executable that's going to run. So the question becomes, well, how could we read in an unspecified number of values from some file, take in some sort of input from a user where they can continue to enter data as necessary? Well, with arrays, we have one of two options. We could create a large array and potentially waste space, so some massive array. Alternatively, we could create a smaller array and potentially not have enough space. The best option right now, where we are in the course, is to use a standard library vector and leverage the pushback behavior, which allows us to grow an array, to grow a vector to some size that, for the most part, should be able to handle an unspecified number of values, provided we have enough space. We will see how dynamic memory allocation will allow us to create resizable arrays at runtime. This is exactly what the standard library vector does behind the scenes. And you will essentially, by the end of this course, have implemented a pseudo vector that essentially performs this allocation as well. Another limitation of arrays is that they do not know their size, so we're stuck passing around an extra variable with them. We will see how classes will allow us to group data together with the operations that act upon them. Currently, you're familiar with structs, so theoretically, you could put an array together with, say, some sort of variables that data members in this case that would maintain the actual capacity of that array and how many elements are stored within it, a size. So that might be one way to essentially manage this a little bit better if we're using these very primitive arrays. Essentially, we will see how a standard library vector does this. It's implemented in a way that creates an illusion of ever-growing collection of objects while storing attributes such as size and capacity and providing a bunch of behaviors for us to interact with. So we'll get into that soon. Another limitation of an array is that unlike standard library vectors .at behavior, indices are not checked before accessing them in an array. So arrays do not prevent us from accessing data outside of bounds. So if we have, say, int r, let's say it's 5, so it contains 5 elements. One error that happens frequently is an off by 1 error, where someone thinks, because it's of size, the 5th index is a logical spot. However, that's outside the bounds of our array. And if you go ahead and do this, in the best case, the program is going to crash immediately with a segmentation fault, which is communicating to us that you're attempting to access memory that you're not supposed to. Oftentimes, however, nothing will suggest an error is occurring and the program will keep running. And this, obviously something else could be stored in this region. So if we're, assigning values and stuff outside the bounds of the array, we can obviously disrupt the integrity of our program's data, and this can lead to the computation of wrong results. And this is a bit tricky to actually track down too. So those are just 3 of the limitations I wanted to cover. I hope that you found this lesson informative, and be sure to play around with arrays in your development environment.